Okay, so this is lesson 4 in the Solving Linear Equations unit for Math 9. In this lesson, we are going to be using some of the algebra skills we've learned in the previous lessons to solve some word problems. We'll either be given an equation already that represents a word problem, or we'll need to come up with an equation to represent a word problem, and then use that equation to solve some different scenarios. Okay, so let's have a look at the 3 examples. Example number 1. A family is going on a road trip. I'm just going to highlight key things as I read them. Their SUV has 75-liter gas tank, and each hour that they drive, they use 8.6 liters of gas. The volume of gas in the car's tank can be modeled with this equation. First thing we're doing here is figuring out what our 2 variables in the equation represent. So we have V, which usually you can kind of tell by the first letter. We're talking about volume of gas here, so V would represent the volume of gas. And you want to be specific. If there are units we're measuring in, you should say so. So it mentions in the question liters, so it's volume of gas in liters. And T, in the question is mentioning, it's talking about each hour that they drive. So T probably represents time here. And that makes sense because the 8.6 liters of gas is what is used up every hour. So, so we'd say time in hours, again, including the unit. Okay, so here's our equation. V equals 75 minus 8.6 times T. And says use the equation to determine how much gas is in the tank. So we want to figure out the volume after 3.5 hours. So what I'm going to do here is replace the time in the equation with 3.5 hours and solve for volume. So my equation becomes V equals 75 minus 8.6 multiplied with 3.5. Now here the volume is already isolated on the left-hand side, so all I have to do is evaluate the right-hand side there. So I'm just going to type into a calculator 75 minus 8.6 times 3.5, and I get 44.9. Now with word problems, it's a really good idea to write your final answer as a little sentence with units. So after 3.5 hours, there is 44.9 liters of gas left in the tank. Okay, next let's solve the next part. I'm just rewriting the equation again. It says determine how long it takes, so the time, before there is 15 liters of gas left in the tank. So this time I'm replacing V with 15 liters and I'm solving for T. So my equation looks like this. So I've replaced the V with 15. And I'm going to need to solve this one by opposite operations and isolating for T. So I'm going to do that now. First thing I'm going to get rid of is the 75. I will subtract 75. And I'll have negative 60 on the left-hand side and negative 8.6 multiplied with T on the right-hand side. Next, I'm going to divide by negative 8.6 on both sides, the opposite of multiplying. And I have isolated T now. And it's about, I have to round this off, but 7.98. So pretty much 8 hours. So it will take, and it's not exact, so I'm going to use the word about. It'll take about 8 hours before there is 15 liters left in the tank. Okay, great. So example 1 is finished. Example 2 is going to be a little more challenging because we have to come up with our own equation this time to model the problem. And then we're going to be doing a similar skill compared to what we did in example 1. Okay, so a family is looking for a venue to hold a party. I'm just going to highlight key things here. An indoor gym costs $150 plus an additional charge of $425 per person. So that's going to typically how you would pay for a venue. You pay a certain amount up front and then per person after that. The community center charges Oh, it's a different place now. A community center charges $2 per person and a flat fee of $2.20. So we're comparing two different venues here. How many people have to attend the party for the cost to be the same? So we want the two costs to be equal to each other. So let's write an equation for, or an expression for the indoor gym. And we need to define a variable here. So let's say let x be the number of people. You should always define your variables that attend, because that's the thing we don't know. So for the indoor gym, the cost is going to be $150 plus $425 times however many people attend. And for the community center, it's going to be $222 plus $2 times x. And we want these two costs to be equal. So I'm going to set those two expressions to be equal to each other. So we only have one variable here. There we go. 222 plus 2x. And I'm going to solve for x. So first thing I'm going to do is get all of the x terms on one side. I'm going to keep them positive. So I'm going to choose to subtract 2x from the right-hand side. And I have 150 plus 2.25x equals 222. Next, I'm going to use opposite operations to isolate that x. So I'll subtract 150. And then I'm left with 72. And finally, I'm going to divide by 225 on both sides. And I have now isolated x, and the answer is 32. So we're going to answer this with a sentence. The costs would, that's a terrible D, be the same if 32 people attended. Okay, great. And last one, if you want, you could pause the video here and try this one on your own, or you can do it with me. This one has a connection to geometry and perimeter. It says, let x represent the length of the unequal side in the triangle below, and determine the length of each side given the perimeter is 18. So perimeter means we're adding all the lengths up together. So let's go ahead and write that then. So the perimeter would be equal to 18, and that's going to be equal to x plus 2.1 plus x plus 2.1. You don't have to put the brackets, but I'm putting them here, plus x. So that's all three sides added together, and we can simplify this by collecting like terms. I have some constant terms and some x terms that I can add together. So I have three x terms, so it'd be 3x, and 2.1 plus 2.1 is 4.2. So there's our equation, and we're going to solve it for x now by isolating using opposite operations. So I'll first subtract by 4.2, and I'll get 13.8 equals 3x, and I'll divide by 3 to isolate for x, 4.6. So let's write a little sentence. The length of the bottom side, right, so that one's x, is 4.6 centimeters. I know it's centimeters because they gave me the units in the original sentence. All right, so that is the end of the lesson.